So hello everybody. For those that you don't know me, I'm Alex Chalkias. I'm a product manager at Canonical, and I'm also overseeing our efforts in the OSM community. I had a lot of help from my colleague from field engineering, Eduardo Souza, so thank him for that, and this is why his name is on this deck as well. So today I want to talk to you about OSM in production. It's going to be a slightly different session than the ones we had the previous days. So previous days were either theoretical or hands-on sessions on the subject of the Hackfest. So today we want to have an open discussion. So this is not going to be me presenting a bunch of slides and you just sitting there and listening. I would like this session to be as interactive as possible. We have specific goals for this session, and they are all related to OSM in production as a discussion. So what we want to do is to clarify the current state of the art. So what is the situation within OSM with regards to its production readiness? We will be talking about new issues or feedback from the field. So we have already some information about specific customer requirements that should be driving new production considerations for OSM. We also have feedback from partners with regards to production. And we want to discuss further enhancements within the OSM community in order to make OSM really robust to address production use cases. So how should OSM be configured to be as efficient as possible for production? This is kind of a breakdown of the topics that I want us to discuss. So the first one is the availability. So we are going to dive into the various OSM components, so as you know them, NBI, LCM, RO, VCA, MON, and POL, and discuss issues related to or considerations regarding their availability. So are they highly available? How can we do geo-redundancy? What's the best way to back them up? And how can we handle disaster recovery scenarios? Then we will move on to possible integrations. So how can we integrate with authentication mechanisms? How to best monitor and integrate with monitoring systems? How to integrate with external systems in order to export, for example, OSM events. Another subject would be deployment considerations. So as you know, we use Kubernetes to deploy OSM. But then what are the substrates on top of which this Kubernetes would be deployed? And also another example of a consideration would be how to deploy OSM behind a proxy or within an air-gap environment. Then we will move on to the kind of a more operations side to discuss capacity. So how do we do capacity sizing, planning, and scaling based on the actual production needs of OSM customers, and of course upgrades and patches. So if a customer requires a quick fix, how do we do that? How do we patch OSM without causing problems into the production environment? And then the last big topic that I want us to discuss has to do with security. So there are a bunch of security standards out there, but what are the ones that we should consider for OSM for production, like ETSI NFV SEC or CIS hardening, or the UK-based NCSE standard or NIST. And then the last kind of other subject has to do with the secret storage. So again, under the umbrella of the security discussion, I want us to see how we can better manage secrets or certificates or private keys. So Going into the first subject, the OSM components, we did a kind of an investigation of what the state of the art is on all the OSM components. So these four, NBI, LCM, RO, and POL, are stateless, are running as stateless services on Kubernetes. They already support high availability. And they also use either Mongo or MySQL as data store to support the highly available deployments. Also, LCM and NBI use MongoDB in order to share files between them. So this is kind of the current situation for these components. We haven't gotten any sort of negative feedback on them with regards to production. So we consider them to be quite stable, and we consider their production readiness to be quite good. So now I want to open the floor for anybody that wants to chip in and maybe bring in their own vision and their own point of view with regards to these components. Basma, you wanted to say something, or anybody else?
Well, I was actually going to ask, just to go back to a previous slide, just for a moment, where you use the term deployment, Kate substrates, proxy, air gap. When we're talking about air gap, we're talking about no route to the internet, or what are the sort of things that you're...
Yes.
Exactly. That's
so
it.
When we say air gap is for whatever security constraint, your machines don't have direct internet access. So how can you deploy OSM in that scenario?
Okay, so that is one of the questions that did come up in the Q&A session yesterday. So if somebody, I cannot recall who asked that question, but this is a good place to further discuss that if if more questions about that are coming up. Sorry to sort of.
No, sure.
Okay.
I mean, clarification was needed. Thanks, Mark. So anybody else has any questions on this slide? If not, we can move forward and keep the discussion going. So I'd like to hear a few words. I don't know if we have the MDLs for these components with us here. I'd like to get maybe their take on their production readiness. What do you think, guys?
Just looking through the list, and I don't think
Yeah.
we have the MDLs here today.
They're not. Okay, so that's fine. Well, this is kind of our initial assessment either way, that these feel quite mature or mature enough to be in a production environment. So let me move on to the next one. So the next one is MON. So MON is currently not scalable nor highly available. So there is ongoing work to enable spreading NFVI and VNF metric collection across multiple instances. So this is quite significant bit of work. I think there was a glimpse of that work presented during, if I'm not mistaken, during the first day of the Hackfest by Subankar. And if I recollect as well, Gianpietro mentioned something yesterday. So this is really important, because essentially you have all these. It's sort of a restriction not to be able to scale out MON in order to handle more metrics from OSM. And then the next really important point that's we've identified is that there is currently no framework to do complex VNF monitoring. So it is very challenging as of now. I mean, it's very challenging nowadays to monitor for example, GNMI-based VNFs. You get all these different protocols like SNMP, GNMI, or REST, And ideally, MON should be able to monitor using any of these protocols, or even better, be protocol agnostic. So VNF monitoring should be easy to do no matter what the protocol, the underlying protocol is. So that's something that we've identified from the field. That's there is still some work to be done on MON for it to be considered like really production grade. So next component I want to talk to you about is the VCA. So having highly available VCA is really important for production. As you know, day 1 and day 2 configuration is mandatory. So configuration must continue to work in the case of a failure of one or more VCA instances. So currently VCA is like, so the Juju controller supports high availability with 3 clustered Juju instances, and it can handle thousands of charms on some modest capacity, so like 32 gig of RAM and 4 cores, which in a production environment, it should be something quite easy to achieve. The thing is that OSM currently needs to know the IPs of all these Juju instances, which is not the case. There is an ongoing work that should be landing in R8, so the next release of OSM, to handle a failover of the Juju instance automatically. Then, with regards to LXD, which is essentially the platform that can host the proxy charms, LXD supports high availability with 3 clustered LXD nodes. And essentially, the LXD nodes and the Juju controllers form pairs that can run on a single machine. So Juju already can handle failover of LXD instance automatically, which is quite nice. Then we have the proxy charms themselves. So currently, the proxy charms cannot scale out within OSM. Juju can scale proxy charms, but OSM would not recognize that scale out. So even if Juju is able to create like 3 instances of the same proxy charm, OSM will still be only recognizing the first instance. So there is work that's ongoing that again will be landing in OSM release 8 to allow the control of scaling of the proxy charms to more than 2 units. So this way, OSM would be able to recognize all the different instances of the same proxy charm. What it still needs to be addressed is templates and guidelines to be able to develop HA proxy charms. So HA proxy charms would be able to synchronize states between the different instances. The templates and guidelines need to be developed to help the community and set best practices on how to develop these HA proxy charms. So the next topic is backup. Currently, we are using 2 different sets of databases that are well and widely understood. We have MongoDB and we have MySQL database. The database store the OSM states, like for example, to handle VNF replication or VNF onboarding. And this data is needed in order to recover OSM in case something bad happens. Then we have backup of the VCA itself. So the VCA backup is needed to restore the VCA state. So VCA keeps the history of all the operations. So backing up VCA ensures that we have some regularity with regards to operations. So the Juju controller has a built-in backup and restore capability. Essentially, the charms contain actions to handle the backup easily. So you don't need to go inside the containers to run a series of commands or scripts to do the backup or the restore, which is quite nice. Also, for the proxy charms, you could do a snapshot of their containers via the LXD or using the underlying file system, which in that case is ZFS. So these two first points are quite good. The fact that we can handle backup and restore of both the Juju controller and of the proxy charms out of the box right now using the VCA capabilities. But what could also be done in order to make this even better is to standardize the backup primitives. So, for example, have a single command like Juju ran action for the OSM backup primitive. Then another thing that we could consider is being able to push backups to external locations. So this is something that is also currently being worked on. Comments, thoughts, questions?
How do you see the restore capability being used? I guess where I'm going with this is, do we have specific point in time that we need to do backups of all the services simultaneously, or if I do a backup of one at 1 a.m. and a backup of another at 2 a.m., what are the sort of operational considerations we would need if I needed to do a restore at that point?
Right, that's a really good question. I think Eduardo has some more hands-on experience on the backup and restore scenario. So, Eduardo, do you mind taking that question?
Backup considerations will always go to the customer. So the person operating OSM or the company operating OSM will always need to have its own backup schedule. Either that's based on deltas or not. That's up to them, and in the schedule will be up to them as well. There's no specific point in time. So whenever they want to do the backup, they'll just run the action, and a file is generated, and they push it to somewhere, an NFS share, an FTP site, something. So the schedule is up to them. The restore part, that is that's basically issuing another action that will just take the backup file and restore it onto Mongo or into MySQL, and that will depend on the charm that we are using. So this is all. So I'm basing this on the assumption that we are using charms, the upstream charms to deploy OSM. So you'll just run an action to restore that into the component that you're seeing. Don't know if that answered your question, Mark.
Absolutely. And I see we've got a couple of questions in the chat. Do you see the chat, Eduardo, or should I read the question?
Yes, I see.
Okay.
So the first question is, since the Prometheus components are not multi-tenant by architecture, how should OSM handle scenarios here? How are backups scheduled based in case of KNFs?
So backups, I've answered this, the part of the scheduled backups. So the charms don't support any scheduled actions. So you'd need a cron job or something to do those scheduling, and that would be on the company or person that's operating OSM. On scaling situations, so you'll always run the backup on the leader. The leader will be the master of the cluster. So you'll always get the latest information on that backup. I think that's the question, right? How will backups happen on sessions from containers?
Yeah, Joe, if you want to confirm that we've answered your question. Okay, great.
Well, okay, I was going to say there's still the outstanding point on, correct, Prometheus components are not multi-tenant by architecture. And as the use of Prometheus in OSM is basically growing, and they're doing a redesign and re-architecture of the monitoring capabilities. That is something that will need to be addressed. So I don't know that there's a clear answer yet. It is being worked on, though.
Also, I got a message from a colleague of mine. The Mongol backup is done on the secondary node just to not affect the availability of the Mongol cluster. Since it's a master-slave architecture, it will do on the slave, so it doesn't affect the rights of the cluster.
Okay, let's move on. So we talked backup. The next subject is geo-redundancy and disaster recovery. So this is quite interesting because we had a specific discussion from a customer of ours. So they wanted to implement an active standby strategy. So this was the requirement. So we did an architecture design with them, and this was what we implemented, but we are still unclear whether this is the best way to go for production. So we had this active standby strategy implemented. So here you have a data center 1, let's call it, that is running normally in an active state. And then you have data center 2 that's running in standby mode, that is constantly receiving state data from data center 1. The charms are able to handle all data replication between the two data centers. And then essentially, since we have all state data replicated in both sites, the customer just wanted to have his own operations team to do the transition from standby to active if that's necessary. So geo-redundancy is overall really critical production considerations, but it can be implemented with different strategies. We can always leverage the power of charms to replicate data from site to site, essentially. But what we are wondering, and this is a critical question that we want to bring into the OSM community, is what if you lose data center 1? So data center 2 won't be able to reach the network functions on data center 1. Does this really make sense as a strategy? Like if we implement the active standby strategy, we don't replicate the network functions. So it's not really clear if it makes sense to also remotely replicate the control of the local network functions. So how common is it going to be that you will lose your data center 1, but you will be preserving your network functions on that data center? So does anybody have any idea, or how would you handle this sort of particular situation, essentially? I would really like to hear from any other MDL, or I don't know if we have any TSC members in the call, but I think this is really quite an interesting topic to discuss, because to us it would make sense in the end to, if we replicate OSM from one data center to another, why not replicate the network functions? Because the network functions are essentially running in the same data center. So if something bad happens, or if you lose your data center from a disaster, let's say, I think having OSM in a different data center won't help you, because you would essentially have lost your network functions that were running on data center 1. So I think it would be really interesting to see the take of the community in how to handle these complex situations, which are really critical for production.
So to chime in again, what I actually was talking about early this week, when we first started talking about the Hackfest overview, we described it as the cellular data path. And in that case, you have your network functions for some core cellular traffic, such as an EPC, and the P gateway, the serving gateways, basically, the things that terminate the encrypted tunnel that comes from the cell phone towards the cellular carrier, and then something, the EPC, the gateway actually, breaks out that tunnel and then sends the traffic out towards the internet.
Yep.
So you would not necessarily have only one of these in one data center. You would have potentially hundreds of these scattered around a continent, a country, wherever it is that you would have. With EPCs getting smaller and smaller, I mean, these used to be purpose-built appliances that contain a massive amount of RAM and a massive amount of CPU power to process them. And now they're getting smaller and smaller. So we're going to be seeing more and more distribution of them, as well as pushes for software running closer and closer to the radio, and then beyond the radio, running on customer premises. So the premise,
you're talking about a highly available topology, right? I mean, having all these P gateways, they form a highly available cluster.
Well, yes and no, because the radio is going to have a path to them. Now, they should be architected locally that, there would be redundancy. Telcos are mandated in a lot of places to have, full 100% replica of all functions. So that way the loss of, a single instance of all functions will not result in a loss of service. It may result in a degradation of service, but it cannot result in a loss of service. So, but in that scenario, you wouldn't necessarily have an OSM at each local or regional data center. You would have more of a global or central data center OSM. And so the loss of the central data center does not result in a loss of the network function. Having OSM replicated to a secondary central data center, which is geographically distributed, makes absolute sense. And it is possible that, DC1, for the term central data center 1 and central data center 2, it's possible that central data center 1 can be lost, but all the network functions are still alive. So in that, and I'm speaking specifically from a telco side of things, that being,
because essentially the network functions don't reside in that central data center; they reside in other ones, and you have that central data center to run OSM to manage and orchestrate the dispersed NFs.
Yes. Yeah, so in the case where you are talking about a smaller OSM installation where it is going to be managing its local cell, its local data center, then geographic redundancy of both OSM and the functions would make sense. Sorry, I just saw there was a question that popped up in the chat. I don't know if you want to finish with this thought train or if we should take the chat message.
No, for sure. I mean, to me, this is something like the active standby strategy is something that we already are implementing with one of our customers. But this kind of opened up the door to a broader discussion on, is there really a unique strategy that we should consider within the OSM community? Should we maybe consider all strategies depending on the use case? So this is really us wanting to brainstorm within the community to see what makes most sense for OSM in production.
Yeah, so here's my side plug. As a bunch of as there are a number of Hackfest participants that are university students, I'll say there is definitely the opportunity for research projects to go on in this area. At this time, OSM does not have any sort of formal opinion on this, and I think it might be more up to the topology of the consumer of OSM that would say, well, this is how we're going to have to do it. So I don't know if OSM can have a particular opinion, but research projects and papers on opinions of here are the strong points, here are the weak points to various options is certainly a great thing for us to invest in.
Sure thing. So we have the question, could OSM serve as a to provision network elements in a production environment? So to me, the short answer would be yes, but I think there are people better suited than me to give more details on that question.
So yes, it can.
Yeah.
So OSM is capable of deploying virtual network functions. So you're able to deploy an infinite number of VNFs that you require in a production environment, and you're able to do it using scaling and day 0, day 1, and day 2 configuration. So that's a good part of it. You're also able to interact with the underlying network. So you'll be able to provision data paths using SDN controllers. So you'll be able to get the most out of your fabric in the data center. You're also able to interconnect those network services between multiple sites using the WIM connectors. So you'll be able to make network services that span multiple sites. You're also covered there. And you're of course able to control physical network functions. So you're able to configure a router, a switch, or any other kind of appliance that you can use a network interface to configure. So either SNMP, REST, whatever, you name it, you can do it in Python. So you're able to configure it. So yes, I'd say that OSM is capable of provisioning the network elements in a production environment. I cannot disclose any names, but I can say that different service providers are currently making that move, and they will be deploying, or they are starting to deploy OSM into pre-production environments with the objective to move on to production environments. Is it clear?
Yeah. Hope that addresses your question, Franklin.
Could you compare OSM with NCO products from Cisco, for example?
I cannot. I don't have that much experience with NSO, but there are probably different spreadsheets going around if you search for it. I know that there is a research paper comparing OSM and ONAP. It was done a while ago. Probably there is something comparing NSO, but I'm not in the right person to do that comparison. Sorry.
Thank you very much.
I should mention that, yeah, thank you, Tolga, for your comments. This is quite interesting. So you mentioned when DC1 is down, we do imply that the Vim could be also down. So yes, indeed, there probably should be an HA strategy that is specific to the Vim. So when the VMs are up in the Vim in DC2, then OSM in DC2 can introduce new VMs that are for the VNFs. So yeah, we could definitely have this healing network service VNF approach for the ones that are lost in DC if DC1 is getting down. So the next subject, now we've talked about all the component availability subjects for production. The next one is about integration. So for integration, we have a couple of subjects that have been identified as important. The first one being authentication. So how do we do external authentication? We can, for example, connect to an LDAP-based system, Active Directory, using, for example, Keystone to integrate with that. I know that there's an SSO integration that is being developed right now. And then we can always use the upstream chunks to help configuring these integrations. So how do you configure for your LDAP integration? How do you configure for your SSO integration? So these are all considerations that one should have in mind when saying authentication for production use cases. So another subject that relates to integration is integration with external systems through the MBI. So external systems like OSS, BSS, they need to interact with OSM. So they will do that through the NBI API. Then it's also important to have different users or systems that need different levels of access. And this can be controlled by setting the proper RBAC policies on NBI. So in order to kind of secure the usage of the northbound interface, RBAC policy definition is definitely something that people need to consider. One of the main asks that we get from our customers is to always restrict the users or the system's activity to what is strictly necessary. We cannot allow them to let's say, exploit the OSM capabilities through the NBI. So this is also something really important to consider for production. Then there's the integration with MON and LMA stacks, so logging, monitoring, and alerting stacks. Here we can have monitoring of the OSM cluster itself or the underlying substrates. So we can have the upstream chunks and gates chunks to integrate with a standard LMA stack. And yeah, the upstream chunks can help monitor both OSM and the substrate. And then we have definitely a need to get metrics from VNF workloads that can also be scraped into external LMA stacks. So we think that the upstream chunks, for which you've seen a lot of their capabilities during this week's Hackfest, is a really good way in order to integrate with monitoring stacks. And then the final point with regards to integration has to do with integration with external systems in case users want to export OSM events to these systems. So, for example, we can already build SNMP traps for Nagios. This is just an example. Nagios can be set up to send alerts to external systems through these SNMP traps. We already have a log forwarder charm that can be used to export logs from the substrate to external syslog servers and other servers. We also have the Prometheus alert manager that can send alerts to external systems. And then we can also use Greylog pipelines to enhance and export logs to external systems as well. So these are multiple ways that we currently use for our customers in order to help them export OSM events to other systems. So yeah, overall, upstream chunks really help with integration, kind of in a streamlining the integrations and abstracting the complexity of integration configuration. But I also want to hear your thoughts on and your experience with integration. So how do you deal with customer requirements related to integrating OSM with other systems?
So just before anyone chimes in, authentication and RBAC policies. That's something that's described in the wiki. The integration with logging, monitoring, and alerting stacks. So we provide all the charms. Anyone can use it. Just need to go online and see how to do it. I'll post the link on the chat. So you'll be able to use the logging and monitoring and alerting stack for anything, and you'll be able to test it and everything. So that's something that you can reuse in your own projects.
Okay, so moving on. Next production consideration has to do with deployment. I see a couple of questions here. I'm not sure if it's a question. It's coming from Joe. If we were able to split the orchestration between OSM and a commercial orchestration, should we have a master orchestrator to manage the same?
So that's a thing. That's a topic that I've seen in the past, both in academia and on service providers. That will depend on what you need the orchestration for. Some service providers might think that OSM is enough. Other might want to have a Uber orchestrator that will link to multiple sub orchestrators. So that depends on the approach. On the academia side, I've seen proposals to have a multi-domain orchestrator that will plug into several OSMs or own apps or whatever you have in terms of orchestration. That's something interesting. But it will depend on the strategy that you want to follow and on the requirements that you have. So that's just my 2 cents on this.
What is the way that we use in order to integrate with these? Like if you have an ONTAP, for example.
Yeah. So if you have a master orchestrator, your OSM will integrate with it through the northbound API. Mm-hmm. So through the NBI REST API, and that's it. The master orchestrator will have a southbound plugin that connects to the northbound interface of OSM, and you control it through that. You'll need to set proper RBAC policies. You'll need to set authentication schemas into that, and the master orchestrator must, through its plugin, must understand the OSM objects that it uses. That's mainly it. That's why we have a standardized northbound interface, so that it can be integrated with external systems, with OSSs and BSSs, or master orchestrators, service assurance kinds of applications, etc., etc. So you can integrate it with anything, as long as it knows how to speak with it.
Okay, thanks, Ed. Any other questions or comments on integration? Okay, I'll move on. So the next subject is deployment. So currently, the most deployments that we've seen are falling into 2 different categories, let's say, of substrates. So one deployment can be on an OpenStack cloud, and another deployment can be on bare metal machines. So with regards to the OpenStack cloud, things that are really important to consider for production is how to set up load balancing, whether the customer has a specific block storage backend that he wants to use. So we should integrate with that. And then in case there's a restriction on the customer side to create the VMs that need to run our containers, we need to specify the VM details for the Kubernetes workers, the master, the ingress, and essentially all the components. So one idea would be to pre-create those Kubernetes flavors, let's say, to be able to bypass the customer restrictions. So if you cannot go onto the customer's OpenStack to define the VMs that are going to host your containers, you would need to have predefined flavors in order to to deploy your containers in the app. And same goes for the VNF. So if the VNF is essentially it can be both on a VNF and a KNF actually. You need to have the VM pre-created in order to deploy it on the OpenStack cloud. And then for bare metal machines, something to consider is how to do the machine provisioning. We are using MAS, so Metal as a Service, which is highly reliable to provision machines, and it's becoming more and more used in the industry to do bare metal provisioning. And then you also need to consider how to do the load balancing with tools like Metal LB or F5. You also need to consider how to do the networking, so how to enable access to external systems like LDAP, OSS, BSS, or a monitoring stack. You would need to set up access to external systems through probably security approved VLANs or firewalls or routes. So what happens in the field is that when you want to deploy your OSM, you essentially are granted manual access by the customer's IT team. So you need to see what are the network elements, no, not the network elements, the network configuration that would be enabled by the IT teams in order for you to grant access for OSM to the external systems. And then the last point that is quite important for production and frequent is the deployment behind a proxy or deployment in air-gapped environments. So what can be done for proxies is that you can define your proxy variables in Juju through the model definition. So you can define your HTTP proxy variables, your APT proxy variables, and then use Juju in order to do the deployment through the upstream charms. And then for the air-gap deployment, what you need to do is definitely set up a repo and a container registry inside the air-gapped environment, and again, leverage the upstream charms for the deployment. So your machines within the air-gapped environment would not have access to the internet, so you definitely need to get all the OSM components through a repo and a container registry that you set up within that environment. So these are all the deployment-related topics that we've identified as being quite important for production use cases, working with our customers and with our partners. I don't know, Eduardo, do you have anything to add to this, or does anybody else has something to add or any questions?
I just wanted to add that proxy and air-gapped environment are really common on the field, either on academia or in service providers. You'll always find environments that require kind of variable setting, and it's really tough to do this by hand. So Juju here is really interesting. It's a really interesting tool where you can centralize all those variables and they get passed to the charms, and it works really well.
The next topic has to do with operations. So there are a bunch of consideration that one has to keep in mind for operations. First of all is the capacity planning considerations. So how do you do sizing and scaling? How do you do capacity sizing and scaling? So that is essentially during the architecture design or the design workshops that you would do with your customers. So here you would need to ask some questions to understand how to size your cluster. So how many VNFs do you intend to run in production? How frequently would you need to change day 1 and day 2 configuration? So this would influence the VCA design. So which is highly dependent on the amount of VNFs that are going to be deployed. Then another question to ask is how many VNF metrics do you need to collect, which would influence the MON and the VCA. And you need to remember that the MON currently doesn't scale, so you probably need to make it bigger to begin with. So these are really important questions that you need to get answers from the customers in order to ensure that OSM would be deployed in a way that it can handle all workloads. So all workloads in a business as usual scenario, but also the workloads in case of spikes. Then another thing to consider has to do with the resource monitoring. So how do you monitor your LXD cluster? How do you monitor your K8s cluster? How do you monitor the Osm components themselves? So things to consider is what kind of monitoring stacks are you seeing out there? What kind of metrics or alerts should be enabled by default in OSM? For example, our LMA stack consists of Graylog, Elastic, FileBeat, Grafana, Prometheus, Telegraph, Nagios, and NRPE. But I can think of any other LMA stack that can work for a specific customer. There's also the Xenos LMA stack, for example, which is quite different than what we've seen within OSM or with our customers as well. So what do you think is the best LMA stack to use in order to have the optimal resource monitoring capabilities within OSM? Anybody wanted to chime in?
When you go into the field, we see different LMA stacks, and Xenos is one of the main ones that we've seen in service providers. And those are LMA stacks that we need to interact with, and that's sometimes a bit difficult because from customer to customer, there are very small variations, and those small variations are a bit hard. So it's interesting to understand the landscape before deploying it.
Anybody else want to comment or ask any question? Okay, I'll continue here. Then things to consider as well has to do with the cluster scale out. So how do you validate that your capacity planning is correct? Because if in the end, if you get more VNFs than you anticipated, you might have not designed your cluster correctly, and you might get failures because in the end, it couldn't manage to handle all your workloads. So you need to be sure that what you've planned for is what you end up with in the end to handle all your workloads, both in business as usual and in case of a spike. Also, how to address alerts. So if you have a lot of VNFs, you need to be able to have an LMA stack that is able to address all the alerts that come from your VNFs. So what Eduardo said before about the ease that Juju brings in order to handle these scale-out scenarios, for example, is that you can just have a Juju command, like Juju add unit to your case worker, and just with that command, you get another couple of instances for your workers. Same goes for the upgrades and patching. So is there any issue that needs urgent fixing? How can we enable that new feature foo that is on that specific branch? So what you can do with the Juju control is that you can have a command like Juju config, the name of the component and the image, and then off you go. You can get you can get your new feature enabled instantaneously. And same goes as the backups that we mentioned before. Like for example, if you do juju run action and the name of the component and the backup, you will be able to do the backup in a single command. So all these are really powerful things that are enabled through the juju controller and the upstream charms. So I see one comment here. Yeah, the sizing example could be really interesting to see. I think we should really consider it as a topic for the next Hackfest, to do some sort of sizing workshop with a theoretical scenario. I think that would be quite nice. Any questions or comments on operations?
You know, I'm actually thinking as we're going through this and these sort of questions and whatnot, I think there's going to be a survey that comes out at the end of the Hackfest. And if some of the questions and some of the things we're talking about here are things that you think would be useful for a future Hackfest, please, you know, either email the Hackfest organizers or add it to the survey or whatnot, so that we can get an idea of, you know, is this something that, you know, if it were on the schedule this week, you would have been very interested in seeing this. The comment saying, you know, sizing example would be interesting to see. That, you know, I mean, obviously due to our experience earlier this week, we wouldn't necessarily be doing sizing hands-on, but theoretical experiments where we can sort of show, okay, you know, based upon the number of deployed instances versus the scale of the instances versus the latency of the network to get to the instance, you know, all of these things would have impacts. And, you know, we may not be prepared right now to sort of say, hey, you know, here's how you do capacity planning. Would love to find out if that's something that would have been interesting.
Absolutely. So I'm just waiting a little bit to see if we have any other questions or comments on this one. Oh, any no latency limitation. Eduardo, did you wanna take that one?
Not really. There are a few questions actually. So focus on, is there a way to stop scaling supposing there's an attack ongoing via alerts to Nagios or other tools? So what you need to do is to set up limits on the Kubernetes pod specs, not to allow it to grow beyond the size of what you're doing. You can also set up alerts on Nagios for that. And so there are a bunch of, so on the LMA stack that we use, you can set up alerts on different levels for different kinds of attacks that you might be suffering. So on Graylog, you'd be able to check, you'd be able to create pipelines to send out messages if you are seeing too many failed attempts on logins. On monitoring, you'd be able to see if you're having too much usage, and you'd be able to set up alert manager on Prometheus to do that. And on Edges, you'd be able to see if the nodes were getting too much CPU time or memory or something like that. So you'll be able to do those. Also, from the standpoint of internal work that we do, we monitor the dependencies for any problematic vulnerabilities that they might have on the images, and we are able to do those kinds of monitoring internally. Going to the latency limitation, I don't know of any latency limitation right now. There's also one from Tolga. Oh, you mean latency limitation between OSM and VNF? If you're doing day 1 and day 2 configuration, the latency between the proxy charm and the VNF might be an issue because it's an SSH connection that needs to be active. You might have a problem there. We have not faced huge latency, so I cannot answer to that. To answer the question from Tolga, so we know internet connections, we already talked about it. but what we do is we set up the repositories inside the data center, and the container registries, and then we point the charms to use those. So it's just a config that we set up, and Juju is able to fetch all the containers and packages from within those repositories. If you use the charmed installation, you'll be able to do that. You just need to set up the repositories internally and pull all the images and packages that are needed.
If I may, I'm just going to jump back into the sort of security concerns, scaling, you know, so I'm going to sort of go to, okay, let's assume there's a denial of service attack on an edge instance or an instance somewhere. And what we don't want is necessarily for OSM to start arbitrarily scaling those instances just because it says, oh, hey, look, we're getting lots of traffic. We must be really popular, because that's just going to end up with a cascade denial of service. We're just going to, service it more and more. Whereas really what we might want is to say, well, when we detect denial of service, we should enter some firewall rules that can just temporarily shut that down for right now. That sort of advanced event correlation is not necessarily something that OSM would have in its scope. They are moving towards monitoring, and like the Prometheus and whatnot. They're sort of going, let's get the existing tools out there to do this sort of stuff. So there was a product out there called EMC Smarts that telcos have used for literally decades. I'm not entirely sure the status of it right now, with the whole Dell EMC VMware hybrid of families. Who owns that product now, where it's at. But that product was great at event correlation, where it could actually give you a root cause analysis saying, hey, no, you're not suddenly gone viral and trending on Instagram or Facebook or wherever. You're actually getting a distributed denial of service attack. And so you would have the external systems do what they do best, and have that sort of OSS BSS integration with open source MANO, so that these tools, where they've got PhD people, PhD graduates working on how to detect this, how to figure out what's going on, let them use their knowledge to figure that out, and just simply tell OSM what to do. So for lab deployments, for being able to get an idea of the capabilities, yes, we've got the sort of scaling and things like that going on. But I'd say in a production environment, you want to partner with real deep experts when it comes to detection. Now that's, I see Alex has moved on to security here, and this is security of the OSM layer. But when it comes to detecting threats in your virtual environment, I don't think that's a space where OSM will ever play. I don't think they're getting into intrusion detection, but OSM certainly will provide the hooks to do something about it once your course of action has been decided on.
Yeah, so that was kind of an easy transition to the slide. So definitely security is a very crucial aspect to consider for production. So the first thing I want to talk to you about has to do with regulation compliancy. So many telcos that we have been working with, for example, need to be FIPS compliant. And have CIS hardening for their substrates. So that's something that if they have that prerequisite, if OSM doesn't support, it's a no-go. So we currently are able to provide both FIPS compliancy and CIS hardening for our customers. But essentially what I wanted to bring here is should we maybe consider this being sort of an out-of-the-box thing for OSM? The other, is this something that should be done inside the project, or should it be handled more in a kind of a distribution level? So that's the question I had here for you. I don't know if anybody has any thoughts on this, but I feel that this is really important to address, because if we want to handle it within the OSM project, we definitely need to see the features that need to come with that to make us FIPS compliant and enable OSM to harden the substrate. Any thoughts?
I don't want to keep piping up, but I do have some opinions on this. And no, Alex and I did not rehearse this by any means. But you know, I'll take a look at commercial distribution support for Linux as an operating system, as an example. So you've got your sort of regular Linux kernel, and security vulnerabilities get reported against that, and there's an embargo process where there may be a vulnerability that gets reported, but not publicly disclosed to do some sort of mitigation. But that embargo period is typically along the lines of 72 hours or something like that, because they don't want to have any sort of perception of, oh, we knew about this, but we hid it from the public. They want to get a response on it as quickly as possible, but at the same time avoid any type of open distribution until a mitigation is found. So when we take a look at commercial distributions, you take a look at the Canonicals and Red Hats of the world, they have packaged up a distribution of Linux, which includes, the hardened kernel. But there are times where, a security vulnerability will be reported to the distribution owner, at which point they have a duty to respond to their customers, of course, still under the embargo rules, but they have a duty to figure out, what is the severity of this vulnerability, and how do we go around doing a patch of that. But ultimately, in the case of the distributions, while it may be immediately available for release through the support channels of Red Hat and Canonical, ultimately the fix lands upstream. So it is both. I see that commercial distributions of OSM are going to need to have the ability to do a security patch ahead of upstream, but I think they also have a responsibility to then turn around and submit that patch upstream.
Yep, absolutely. So just to not stall further, because we still have 6 minutes, and I have another slide to wrap this up. So the next point I wanted to make with regards to security has to do with the monitoring of dependencies for vulnerabilities. So how do we want to monitor for our dependency trees? One option would be to add open source tools like OWASP Zap or Encourage or any other open source tool that can help with that in our upstream CI/CD pipeline. So, well, that hints to you, Mark, again, but I mean, this is something that is really important in order to be proactive with regards to handling vulnerabilities. So if you have an issue and you want to fix it, what are the dependencies that you need to keep in mind, and what is the best tool that we could use in order to detect these dependencies to sort of be able to fix any issue with regards to vulnerabilities in a streamlined way and not get abruptly caught in some dependency chaos. So I think that this is definitely something that we could do to add an open source tool in our upstream CI/CD that would help us monitor vulnerability dependencies. Do you agree? Do you think that's a good idea? I mean, I'll be happy to hear your thoughts.
That's something that we already do internally at Canonical for our distribution. And this is something that the DevOps MDL, which is Mark, should have a strong opinion on, and I think he has. So I think he can comment better on this in his plans on how to do it upstream.
Yeah, before I get on a soapbox, I'll just take a look at the time and say, yes, OSM's at the inflection point where it is time to really start focusing on production use. That's part of the reason why we're seeing sessions like this at the Hackfest now. We are definitely shifting and looking at ways of not just license scans in the software, but lint checks, deep checks, static code analysis, CVE exploits, etc. We're looking for common patterns. This is a work in progress. And again, sort of a bit of a point out to any students that may be in there, or anyone who's interested in this subject and looking to be able to contribute somewhere. This is an open source community where if any of these topics that you've seen today are of interest to you and you have a feel that you may have something to offer, be it just participating in discussions or actually coding, OSM is open source. We would love to hear from you. We would love to have you on board.
That's right. So moving on to the next topic, it has again to do with CVE patching, but now we are speaking about CVE patching of the OSM Docker images. So how can we do that? Our take would be to have automatic build process for the CVE patched images, and then store these images somewhere, like for example Docker Hub or any other hub that can store the Docker images. So this is another way that we also are using in our Canonical distribution to address vulnerabilities of the entire Docker image. So I think this is also something really important that the community should consider having upstream as well. I think Ed, you might have another comment on this one, no?
On the standards?
On the CVE patching.
Yeah, that I already covered that on my previous comment. But yes, that's something that we do for our own images of Charmed OSM, and it falls under Mark's lead to do that for OSM and to help the community and steer the community into the right path on how to do that.
So the next part of how we ensure that OSM is fully security compliant has to do with the actual standards. So as I said in the introduction, there are different standards that address different needs, and it would be quite common to have a customer bring us the standards that he needs to adhere to. So etc NVSec, NCSC, NIST, which are the most important standards that upstream OSM need to follow or to be compliant with. So this is really an open question, but I think this is gets more and more important while we see OSM going towards production. So I'm not aware of any, let's say, targeted work that has been done in order to address this, but I definitely think this is something that we need to consider and probably do some community brainstorming around and have some specific plan on how to address. So I don't know if we have any, let's say, security standards enthusiasts or experts in the audience, but I'd love to hear some comments on that. And if we don't, it can still be a subject for the next Hackfest, of course. Okay, I don't want to stall any longer because we are actually already out of time. So I just want to wrap up the presentation smoothly. So the last topic around security, I think we've already sort of covered it with comments from both Mark and Ed, based on the question from Joao. It has to do with the Kubernetes security. So Kubernetes security is a very hot topic. We use Kubernetes as a substrate, so we need to address any issue that can arise based on that. So one thing that we have gotten from some customers has to do with the authorization mode for Kubernetes. So currently, the default authorization mode is the always allowed mode, which is kind of not the stricter it could be. So what should we do when the customer says, I don't want the always allow mode, I need to be stricter? Could we use the Kubernetes RBAC to address this? Probably, yes. So this is something that has to do with your customers' security restrictions. Then I think Eduardo mentioned this before. A pod can get an infinite amount of resources, which can cause a denial of service attack. So in order to protect ourselves from that, we need to define resource quota per pod so that every pod could get a limited amount of resources, therefore protecting us from the DOS. And then the last point on Kubernetes security has to do with security contexts. So security contexts are all about limiting the pod execution to a specific user group, avoiding unauthorized privilege escalation that may result in a compromised substrate or a compromised machine. So we need to think of security contexts with the customers in order to say what are the proper rights to allocate to different users or groups, and what are the actions that we want every group to be able to do so that we can protect the substrate from any malicious attacks. The last subject has to do with secret storage. So currently we are using different secrets within OSM. So we have database, message queue, or external systems credentials that we store. We also store SSL certificates or encryption keys. Currently, we use EasyRSA for certificates management within Kubernetes. But the issue is that OSM currently does not have a coherent approach for secret storage. Some secrets are stored in Mongo, others are shared in Docker environments. So we feel that it's really important to have a consistent way to store all the different secrets that we use in OSM. So the suggestion is to use a new mechanism for both certificates and private keys, which is Vault. So Vault is already integrated into Kubernetes. It can provide secret storage to OSM, and it's one of the approaches that is also used in NCSC security standard for key and secret storage. So it's really a tested and proven solution in the field, and we feel that it can bring a lot to the OSM production security readiness and story. So this is kind of the suggestion that we wanted to bring forward to handle this concept. So I'd love to hear any comments on that, because I think we should really take this forward and make it part of the upstream. And actually, this is my last slide, so I'll be wrapping up after that. So let me hear your thoughts if you have any.
Yeah. So again, this is a call out to participation. If somebody's got interest or availability in this area, but yeah. So I guess for a bit of a wrap up, once again, I'll sort of highlight that there is the ecosystem day that is coming up this afternoon. So please, everyone, hang out in this channel because that's where, or this meeting, because this is where it will be happening. And these are going to be, actual vendors, actual customers, actual implementations, and real world experience of what's going on with OSM in the real world. So definitely invite you to continue to participate in that part, as well as any of the sort of thoughts or ideas that have been brought forward here. Take a look. If you've taken notes of any of them, see where people are headed with some of these, and again, open call. This is an open source community. Would love to if you've taken anything away from this that has resonated with you and you feel you would like to participate, we would love to have you here. And the ecosystem day is another way of being able to see what's really happening. If you're on the vendor side, if you're on the integration side, this is a good place to learn more information about what's happening and possibly get some ideas for projects of your own. Yeah, I guess with that, being a little bit over time, I'd like to say to everyone, hey, have a great lunch, and we'll see you back here for the ecosystem day. Thank you very much.